Hello Pharma guys, welcome to our channel Easy Learn Pharma. Today I am going to discuss about the last portion of the emulsion. So what is that portion? That portion name is stability problems of emulsion. Okay, that means in this part I am going to discuss about what are the problems affect to the stability of emulsion, or what are the factors affect to the stability of emulsion, or what are the changes usually occurring during the preparation and storage of emulsion. Okay, so my dear students, in this class I am going to discuss about what are the changes usually occurring during the preparation and storage of emulsion. That's why you can say that is the instability of emulsion. That is the instability of emulsion. Okay, so that is the most important portion of the emulsion. Maximum time in the semester the question will be arise regarding the stability problems of emulsion. So now come to the point. Okay, so my dear students, so before going to the stability problems of emulsion, first of all you should know what do you mean by stability. What do you mean by stability of a product? That's why you can easily understand what I am telling regarding the stability problems of emulsion. Okay, so stability means what? What do you mean by stability? Stability means, or the what is the meaning of stability of a product? That means it to maintain maintain all the properties, all the maintain all the properties of a product. Okay, so when the product maintained all the properties, in that time you can say that is the stability of a product. So which type of properties that maintain, that's why you can say that is the stability of emulsion. And that all the property, that means it includes the purity. Okay, purity, quality and efficacy. and efficacy. Okay, so my dear students, when the product maintained all the properties, in that time you can say that is the maintained, or that is the stability of a product. So which type of property? Now that one is purity, and quality and efficacy. So my dear students, when the product maintained the purity, quality and efficacy throughout its shelf life, okay, throughout its shelf life, in that time you can say that is the stability of a product. That is the stability of a product. So now come to the point, what do you mean by stability of an emulsion, or in which time you can say that is the stability of a emulsion? Clear? So my dear students, in which time you can say that is the stability of a emulsion. So when the dispersed globules are uniformly distributed throughout the dispersion medium, in that time you can say that is the stability of an emulsion. Clear? So okay, or when the emulsion should be maintained the chemically stable, or when the emulsion should be chemically stable, or there is no microbial contamination during the shelf life. Okay, so in that time also you can say that is the stability of an emulsion. Okay, so again I am repeating that part, in which time you can say that is the stability of an emulsion, when the dispersed globules are uniformly distributed throughout the medium during the storage condition stable, or the emulsion should be chemically stable, and there is no any microbial contamination during the shelf life. In that time you can say that is the stability of an emulsion. That is the example. Okay, so my dear students, listen carefully what I am telling. So these are the dispersed globules, dispersed globules, and this one is the continuous phase. Okay, this one is the continuous phase or dispersion medium, and these are the dispersed globules. Okay, so when the dispersed globules are uniformly distributed throughout the medium during the storage condition, in that time you can say that is the stability of an emulsion. Or when the emulsion should be chemical stable and there is no any microbial contamination during the shelf life, in that time you can say that is the maintenance of stability. That's why you can say it is a stability of an emulsion. Clear? So now come to the point. When you have to prepare, or when you have, after preparation, when you have to store, that means during the preparation and during the storage condition, what are the problems will be arise. That's why the emulsion converted into the instability of emulsion. Clear? So in during the preparation and during the storage condition, what are the problems will be arise? There are three types of problems will be arise. That's why you can say that is the instability of an emulsion. Three problem, three types of problem. So first one is cracking. Okay, first one is cracking. Second one is creaming, and third one is phase inversion. Phase inversion. Okay, so my dear students, when you have to prepare, okay, so during the preparation and during the storage condition, what are the changes occurring, or what are the changes usually occurring? That's why you can say that is the instability of emulsion. So there are three types of changes will be visible during the preparation and during the storage condition. So first one is the cracking, or you can say breaking. Okay, cracking or breaking. If the emulsion will be cracking, then it leads to the instability of emulsion. If the emulsion having creaming, then it leads to the instability of an emulsion. If the phase inversion will be produced, then it leads to the instability of an emulsion. So one by one I'll be discussed. Clear? So first one is the cracking. Okay, so my dear students, first I am going to discuss about cracking part. Cracking or breaking. Clear? So, what do you mean by cracking? What do you mean by breaking? So, cracking means the completely separation of two layers. Okay, the complete separation of two phases of dispersed phase or continuous phase. Clear? The diagram is okay. So, my dear students, listen carefully what I am telling regarding the cracking. So, what do you mean by cracking? Now, cracking means the complete separation of two layers. One is dispersed phase, another one is the continuous phase. Due to coalescence of globules, or due to coalescence of dispersed globules during the storage. Okay, that means after preparation, or during the preparation, or after preparation when you have to store. Okay, during the preparation and during the storage, when the globules, okay, when the globules are contact to each other, okay, and or when the globules are coalesces to each other, and it form a large globules. Okay, it form a large globules. That's why it leads to separate to each other. And when the two phases will become, okay, in that time you can say that is the cracking or breaking. Clear? So that means it is the complete separation of two layers. This one is the dispersed phase and this one is the continuous phase due to coalescence of dispersed globules during the storage condition. Clear? That's known as cracking, or that's known as breaking. Okay, and that cracking leads to the instability of an emulsion. Clear? So now come to the point why the cracking will be occurs. Okay, or what is the reason behind the cracking will be formed. Okay, so what are the reasons? There are so many reasons are there, that's why the cracking will be formed. Okay, so what are the reasons? Now first one is addition of addition of opposite type of emulsifying agent. Okay, and second thing is by decomposition and precipitation of emulsifying agent. Okay, and third one is by addition of common solvent. Okay, and next one is by growth of microorganisms, and last one is by temperature. Okay, so my dear students, why the cracking process will be occurs, or why the cracking will be formed, that's why the emulsion converted into the instability of emulsion. Clear? So due to so many reasons are there, that's why the cracking will be occurs. So first one is by addition of opposite type of emulsifying agent. That means when you have to add the opposite type of emulsifying agent in the preparation of emulsion, in that time it leads to the cracking. That's why the instability of emulsion will be formed. Okay, next one is the by decomposition and precipitation of emulsifying agent. Okay, so when the emulsifying agent, okay, so when the emulsifying agent decomposed, or when the emulsifying agent precipitation, in that time definitely the emulsifying agent cannot work properly inside the preparation of emulsion. That's why it leads to the cracking, and you can say it is the instability of an emulsion. The next one is the by addition of common solvent. Okay, so when you have to use some common solvent during the sorry, when you have to use some common solvent in the preparation of emulsion, if the common solvent mixed all the ingredients, that may be oil, that may be emulsifying agent, or that may be water, if the common solvent mixed all the ingredients and it form a clear solution, then definitely it leads to the cracking. Okay, last one is the by sorry next one is the by growth of microorganisms. Okay, so during the storage condition, or during the storage, when the microorganism growth inside the emulsion, definitely after some time the emulsifying agent will be degraded. Okay, that's why it leads to the cracking. Next one is by temperature. Okay, when you have to store the emulsion, if in that time the temperature will be enhanced inside the product, then definitely the viscosity will be less. That's why it leads to the cracking, and you can say that is the instability of an emulsion. So my dear students, so one by one I'll be discussed. So first one is the by addition of opposite type of emulsifying agent. Okay, so which type of emulsifying agent you have to add, that's why it leads to the cracking, and you can say that is the instability of an emulsion. So first one is the by addition of opposite type of emulsifying agent. So I'm giving one example so that you can easily understand what I'm telling regarding the opposite type of emulsifying agent. Okay, so there are two types of emulsifying agents are there basically in that phase. First one is soap of monovalent, okay, and soap of divalent. Okay, so my dear students, Listen carefully what I am telling regarding the by addition of opposite type of emulsifying agent. Okay, definitely you have to add opposite type of emulsifying agent. So what are there? Now, first, when you have to add, sorry, soap of monovalent and soap of divalent. Clear? So soap of monovalent emulsifying agent produce O by W type of emulsion. Okay, and soap of divalent emulsifying agent produce W by O type of emulsion. Clear? So when you have to add the soap of monovalent in soap of divalent, then definitely these are the opposite type of emulsifying agent. And when the opposite type of emulsifying agent mix together, definitely it leads to the cracking, and you can say that is the instability of an emulsion. Clear? Very simple. Soap of monovalent that produce the O by double type of emulsion, and soap of divalent that produce the double by O type of emulsion. So these are opposite type of emulsifying agent. When the opposite type of emulsifying agent mix together, it leads to the cracking, and you can say it is the instability of an emulsion. Clear? Next one is the next point is by decomposition by decomposition and precipitation of emulsifying agent. Clear? So mind the students, by decomposition and precipitation of emulsifying agent. So when the emulsifying agent decomposed and when the emulsifying agent precipitated, definitely in that time the emulsifying agent cannot work properly inside the emulsion. Definitely it leads to the cracking, and you can say it is the instability of an emulsion. So I am giving one example so that you can easily understand how the emulsifying agent decomposed or how the emulsifying agent precipitation. Okay, suppose you have to prepare the alkali soap, the alkali soaps of emulsion. Okay, suppose you have to prepare the alkali soaps of emulsion, and in the alkali soaps of emulsion, if you will add the acid. Okay, so prepare the alkali soap of emulsion. That is example is turpentine. That is example is turpentine turpentine liniment, turpentine liniment emulsion. Okay, so if you will prepare the turpentine liniment emulsion, that is the alkali soaps of emulsion. Okay, and when you have to add the acid, after adding the acid in the alkali soap of emulsion, the emulsifying agent decomposed. Okay, that's why it leads to the cracking, and you can say that is the instability of an emulsion. Clear? So next example is how the precipitation of emulsifying agent. Okay, suppose you have to use sodium chloride. Okay, sodium chloride add with add with potassium soap of emulsion. Potassium soaps of emulsion. Okay, if you will add the sodium chloride in potassium soap of emulsion, so what will happen? Now, when you have to add the sodium chloride with potassium soap of emulsion, in that time that process is called known as salting out process. What? Which process? Now, salting out process. Okay, so when you have to add the sodium chloride with potassium soap of emulsion, that process is called as salting out process. In this process, the water is completely reduced and the emulsifying agent precipitated. So when the emulsifying agent precipitated, in that time it leads to the cracking, and you can say that is the instability of an emulsion. Clear? So the next point is by addition of by addition of common solvent. Okay, so my dear students, how the common solvent leads to the cracking. Clear? So by addition of common solvent, that means when you have to use some solvent in the emulsion, definitely that solvent may be miscible or may be dissolved or soluble in oil, emulsifying agent and water. Yes or no? Huh? Yes or no? So when you have to add the common solvent in a emulsion, it may be miscible or solubilized in oil, emulsifying agent or water. So if miscible or if dissolved or if solubilized in these ingredients and it form a clear solution, okay, in form a clear solution, definitely it leads to cracking, and you can see that is the instability of an emulsion. So I am giving one example so that you can easily understand how the common solvent dissolve in these three ingredients. Okay, that ingredients name, that example is alcohol. Okay, so alcohol is a common solvent. That alcohol, when we have to prepare the turpentine oil emulsion, in that time when we have to use some alcohol, that alcohol completely dissolved with turpentine oil and dissolved with soft soap emulsifying agent, soft soap of emulsifying agent, okay, and dissolve with or solubilize with water. Okay, so when you have to prepare the turpentine oil emulsion, in that time if we will add the alcohol, that alcohol common solvent dissolve with turpentine oil, dissolve with soft soap and solubilize with water, and it form a clear solution. Okay, and definitely it leads to the cracking, and you can say that is the instability of an emulsion. Clear? So the next parameter is by micronization, sorry, by growth of microorganisms. Okay, that means when you have to store, okay, that means after preparation, when you have to store the emulsion in a container during the storage condition, if in that time the product may be contaminated, the microbes will be growth. Okay, so after growth of microorganisms, definitely the emulsifying agent decomposed or the emulsifying agent deteriorated or the emulsifying agent decomposed. So due to harm or due to decomposed of emulsifying agent, it leads to the cracking. Clear? So definitely you can say that is the instability of an emulsion. Clear? So the next parameter is by temperature. Okay, so after preparation the product, okay, after preparation the emulsion, you have to store full place. If in that place the temperature will be more, okay, if the temperature will be increases inside the product or inside the container, and definitely the viscosity will be less inside the product. Okay, so if the temperature will be more, and definitely the viscosity will be decreased, and when the viscosity will be decreased inside the medium, in that time all the dispersed globules are again recoalesced to each other and it form a large globules. That's why it leads to the cracking. Clear? And in that time you can say that is the instability of an emulsion. So you have to maintain the viscosity inside the medium. That's why all the globules are uniformly distributed throughout the medium, and you can say that is the stability of an emulsion. Clear? So that is, so by such type of reasons the cracking will be occurs. Clear? So now come to the point, creaming. Okay, creaming. So what do you mean by creaming? Again, I am repeating the first part. What do you mean by cracking? So that you can easily understand what do you mean by creaming. What do you mean by cracking? Now, cracking means completely separation of two layers. One is dispersed phase, another one is the continuous phase due to coalescence of dispersed globules during the storage condition. Clear? So the separation of two layers. dispersed phase and continuous phase. That phase you can say, or in this stage you can say that is the cracking or breaking, or in which time you can say that is the creaming stage. Okay, I am giving one example so that you can easily understand what I am telling regarding the creaming phase. Okay, so these are the dispersed globules are uniformly distributed throughout the dispersion medium. So that is the stability of an emulsion. Clear? So okay, so my dear students, you can easily understand what I am telling regarding the creaming and cracking. Okay, listen carefully. So what I'm telling now, when the complete separation of two layers, this one is the complete separation, this one is the dispersed phase and this one is the continuous phase. That is called known as cracking. This one is the stable emulsion, because in this stage all the dispersed globules are uniformly distributed throughout the medium. Okay, this one is the cracking. So creaming, what do you mean by creaming? Creaming means what? Now when the dispersed globules, upward movement of the dispersed globules. Okay, so creaming is defined as the upward movement of dispersed globules. Okay, so what do you mean by creaming? Like creaming is defined as the upward movement of the globules and form a thick layer on the surface of the emulsion. In that time you can say that is the creaming. Listen, okay, so look at this picture. In this picture these are the small globules. Okay, it cannot form a large globules. Okay, when it form a large globules it will separate to each other and it form a two layers, but in this case the small globules are float on the surface and form a thick layer on the surface. In this stage you can say that is the creaming stage. Okay, so how the creaming will be formed? Now during the preparation or after preparation, when you have to store, okay, after preparation when you have to store, in that time the globules moves upward direction, and form a thick layer on the surface of the emulsion. This stage is called known as creaming, and that stage is a temporary phase. Okay, mind the students, listen carefully what I am telling. The cracking stage is not a temporary stage. If the cracking will be occurs in this phase, you can't redisperse again. Okay, all the globules. It can redisperse all the globules again. But if the creaming will be formed, okay, if the creaming will be formed, you can redispersed again, but it is very difficult by using some steering, by using some mechanical steer, by using some Silverson homogenizer, or by using some hand homogenizer. So by using Silverson homogenizer, hand homogenizer, or mechanical steer, the creaming stage you have to avoid it. Okay, so how to avoid the creaming stage? Now by using some steer. Okay, so when you have to using some steer, in that time it reduces the globule size. That's why again all the globules are redistributed throughout the medium and the creaming stage is avoided and it form a stable emulsion. Clear? So the creaming phase is the temporary phase or the. So now come to the point, how to explain the creaming. Okay, how to explain the creaming. So to explain the creaming, a law is there, that is Stokes law. That is Stokes law. So which law? Stokes law. Okay. So what is the formula? That formula is V is equal to 2r square d1 minus d2 into g divided by 9 eta. So, my dear students, a Stokes law, in the exam point of view, Stokes law is arise 2 marks. Okay, in that time you have to explain the total creaming part, not cracking part. The rate of creaming explained by the Stokes law. So, what is the formula? Now, V is equal to 2r square d1 minus d2 into g divided by 9 eta. Clear? Okay, so B means what? Now B is equal to rate of creaming. B is equal to rate of creaming. And R square or R is equal to radius of the globule. Okay, and D1 is equal to density of the dispersed phase and D2 is equal to density of the dispersion or continuous phase. Okay, and G is equal to gravitational constant and eta is equal to viscosity. Clear? So, in the Stokes law, it derives the rate of creaming. So, V is equal to rate of creaming, R is equal to radius of the globules, D1 is the density of the dispersed phase, D2 is equal to D2 is the density of the dispersion medium or continuous phase, G is equal to G is the gravitational constant, and eta is the viscosity of the medium. Clear? So now come to the point. What is the relation in between them? Clear? So V, rate of creaming, is directly proportional to 2r square d1 minus d2 into g. That means the rate of creaming is directly proportional to the radius of the globules, density of the dispersed phase, density of the dispersion medium, and gravitational constant. Okay, and it is inversely proportional to the viscosity. That means when you have to explain the rate of creaming by the radius of the globules, that means when you have to, if the globule size will be more, okay, if the globule size will be more, then definitely, listen, that is directly proportional to, okay, directly proportional to the radius of the globules or density and gravitational constant. So if it is increased, then definitely the rate of creaming is increased because it is directly proportional to, okay. So the viscosity, if it is increased, so it is the decreased. Okay, so now come to the point, radius of the globules. If the globule size will be more, then definitely, or if the globule size is increased, then definitely the rate of creaming will be more. So how? Now if the globule size will be more, then definitely it attached to each other and it float on the surface, okay, and the rate of creaming will be more. Here, so if the globule size will be decreased, then the rate of creaming will be decreased. Okay, and next one is the density of the dispersed phase. Okay, density of the dispersed phase and density of the continuous phase. Okay, so if the large density, okay, if the large density in between the dispersed phase and continuous phase, okay, so dispersed phase and continuous phase, if the large difference will be occur, then definitely the rate of creaming will be more. Okay, there is the globules and this one is the continuous phase. If the large difference, then definitely the rate of creaming will be more. If the small difference, then the rate of creaming is decreased. How? Now if the small difference, then definitely all the globules are distributed throughout the medium. If the large difference, that means all the globules move upward direction. Okay, and next one is viscosity. Okay, if the viscosity will be decreased, then definitely the rate of creaming will be increased. How? Now listen, if that is the emulsion. Okay, if there is viscosity will be less, okay, if the viscosity will be less, then definitely the globules move one place to another place very easily, and definitely if the all the globules are attached to each other or recovalent to each other, and it form a large globules, or in within fraction of time all the globules move upward direction and form a thick layer. So if the viscosity will be more, so it cannot be move upward direction and it cannot recoalesce to each other. So that's why you have to maintain the viscosity inside the emulsion. Okay, so if the viscosity will be increased, so the rate of creaming will be decreased. If the viscosity will be decreased, then the rate of creaming will be increased. Clear? So that is called known as Stokes law. Okay, the rate of creaming is explained by the Stokes law. V is equal to 2 R square D1 minus D2 into G divided by 9 eta. Clear? So now come to the point. The next parameter is phase inversion. So next parameter is phase inversion. Okay, so what do you mean by phase inversion? That means if you will prepare the O by W type of emulsion, and that O by W type of emulsion converted into the W by O type of emulsion, that is the phase inversion. Okay, so if the O by W type of emulsion converted into the W by O type of emulsion, that is called as phase inversion. So how it is possible? Now by using some electrolyte, okay, or by using some emulsifying agent, or by using some solvent, okay, that's why the phase inversion will be occurs. Okay, so my dear students, the emulsion chapter is completely covered. Okay, thank you very much, my dear students. Thank you.